Hi, this is Michael from Rigor Consulting, and today I just wanted to give you a little demo of a suite of tools that I have available. This is what I call the Lean Six Sigma suite, and it consists of several different templates and different reference cards that you can use as a Six Sigma professional, or maybe you're getting just involved with Six Sigma, and these allow you to do a lot of what you would traditionally do with a statistical software. So if you're on a shoestring budget, you're just starting out a Lean Six Sigma journey with your organization, or you're trying to do your own consulting, this is a great resource to kind of bolster your ability to conduct analysis as well as have a kind of a finished and professional look to it. So what we have here is just several different folders, a folder full of standards, which aren't really analytical tools or templates, but certainly they're there, things like working standards and 5S check sheets and whatnot. In the define phase, we've got things just to kind of help people get started, scoping out the project. Gantt charts, project charters, value stream maps are thrown in there, depending on how you like to start your project. In the measure phase, we've got all sorts of different templates. Again, we've got that 5S checklist in there. We've got different measurement tools, whether you're trying to figure out what sigma level a process is already, or you're trying to do some more root cause analysis, like cause and effect matrices and fishbone analysis. There's all sorts of things in there, including what I like is a waste criticism to help you throughout a Gemba walk. Really, you go in, you observe the Gemba, and then you kind of look through your, use a critical lens to look at the observations you've recorded. There's also a reference card like this types of data that talks all about the data types and how the types of data you use will inform what statistical tests you can use in the analyze phase. In the analyze phase, we've got all kinds of different analytical tools to help people visualize data as well as do some high-powered statistical analysis, which we'll get to in 1 second. In the improve phase, we've just got a little bit of things. We've got, an IIP and another template here for data collection visualizations. And then finally, in the control phase, we do just have the control plan. So, all being said, there's about 30, maybe 35 different templates in there, and they're all pretty high-powered. I actually wanted to go over a couple of them in this demo with you. You might have seen in that measure phase of the measure folder that there was a whole separate folder for MSAs, measurement system analysis. And this is something that you almost always have to rely on Minitab to do. Nobody actually knows the math behind doing MSAs. I did a lot of research and I did all the math and I put it into a spreadsheet. And this is kind of the result of that. So here, what we have is different operators, operator 1, 2, and 3, and they're measuring 10 different samples, widgets. So if you know how to conduct a measurement system analysis, this will look very similar to you, where you've got, you're measuring the same thing several times in these different trials. You can see here that in all of these cases, except one, this operator agrees with him or herself. And over here you see that there is a general agreement and it doesn't look like they've missed anything. We've got the average, we've got the range, and you can see that the range is 0, which is to say that there were no differences in the measurement between trial 1 and trial 2 of the operator. This data here automatically populates a report over here, which will give you something that's very similar. I think it's actually, better than what Minitab will report out. And what it does is it identifies and it helps you visualize the repeatability of the process, which is within the operator. What is the variance of operator 1 from trial 1 to trial 2, the variance of operator 2 from trial 1 to trial 2, as well as the reproducibility. What's the variance between operator 1 and operator 2, the total variance in the process, and then the variance between parts. Ideally, we would want all of the variance between measurements to be in the parts. That would mean that we would have a perfect measurement system. But I do have a guide here. This is something Minitab doesn't provide, which really helps you identify how good is my process. And this is just some rule of thumb here. So here we've got less than 20% is usually acceptable in industry. Between 20 and 30% is kind of marginal performance. And then anything where 30% of all your measurement variation is within the measurement system itself. Let me say that again. 30% of all the variation that you measure is within the measurement system itself. That's something you want to improve the measurement system on before you really start doing any kind of process improvement. We also have some visualizations here which just kind of highlight where the differences are between operator 1 and operator 2. In this case, we didn't have a third operator, so we see his series or her series is 0, and we see that there's general agreement between the two. This seventh widget in the sample was the one where we had the most variation, but other than that, there was very general agreement between the two. And again, this is just the range of the two measurements. Again, it's something that Minitab is going to provide for you. Here, you don't have to pay that hefty licensing fee. We'll also go here, just the data, I'm going to put in 15 for this trial number 2. So something egregious, somebody messed up somewhere. What does that look like? Well, we see here that our reproducibility and our repeatability have increased. In this case, the reproducibility is no longer in our safe green zone. It's increased into the non-safe zone. Reproducibility, there's still general agreement because we only changed 1 data point out of 40 data points. So that's still in the green zone for us. But the total gauge R&R, the total measurement system variance, is too high. It's exceedingly high. And for that reason, we say it's not a good measurement system. Something went wrong. And again, we see that the range greatly increased. That 7 is dwarfed by this huge range that we have here. So that's just one template that this suite has. It's very high powered. It's something that a statistical software would be able to do, and it's right there within Excel. Another one that I wanted to show that I think is really high powered is this 3-factor DOE. So design of experiments is kind of a 6 Sigma black belt, sometimes master black belt level. And I'm not going to get into the details of how it all works because it is a little proprietary. But here what we have is we've named different factors that we're looking to test and see the sensitivities, the main effects, and the interactions between. This informs a kind of a design of experiment plan on what settings we're going to put at them, high settings, low settings. And here we've kind of just annotated what those settings might be. For temperature, it might be 45 degrees to 90 degrees. Viscosity, if we're changing some viscosity setting in a fluid, we're changing that, and then rotations per minute, we can also change that. When we've conducted this DOE, what we get is we get a main effects plot. It looks a little bit different than what you would see in Minitab, but it is a main effects plot nevertheless. And we see what factors are the largest of all of the factors we've looked at. And we also see the interactions. Is A interacting with B? Is A interacting with C, and is B interacting with C, and then are they interacting with each other? Down here, we can get into more detail where we're looking at interaction plots. And again, we can take a look at it at each level. So as you click here, obviously there's no interaction just of A, nor will there be B or C. But when we look at A and B, we see, yes, there's definitely an interaction happening there, right? Because one main effect is crossing the other. We can look at these and see that there is no interaction, and B and C that there's no interaction as well. And then of course we can't do 3-dimensional graphing on here, so you're not going to get that in A, B, and C, but you can clearly see that there's no significant effect there. And I think everybody would agree with that. So again, just another example of high-powered statistical analysis that's usually reserved for expensive Minitab softwares, statistical licenses, and it's right here. It's in the palm of your hands. You're kind of giving away the farm here, but it's something we like to do to make you seem more polished and know what you're talking about. Just some other things, maybe not so analytically focused, but I have this nice IIP here. What I like about this is it it's got this PDCA. So depending on where you are in the process, if you're in the check stage and you move this, it has a nice visualization. It's all about visual management and lean. So this is a nice lean tool where you can, IIP is the itemized implementation plan. So where you are, what you're working on and where you are in delivering and implementing that countermeasure into a process. So again, just kind of a nice visualization to help people and give you a polished look. And then finally, maybe one more thing, a statistics reference card. So this is not a tool to be used so much as a tool to be used in the project so much as it's a tool to be used for yourself. What this is just kind of a repository of all these statistical distributions and kind of what they have with the parameters. So here you go to the normal distribution and you see all kinds of different distributions, what the parameters are, what some of the values are as well. And then as you go into different areas here, you see different distributions and what these parameters are here as well. So you've got 9 different distributions that will give you everything you've ever wanted to know and more about these statistical distributions, just to give you a little bit more knowledge if you're using one that you haven't used in a long time. We all want to be in the normal distribution, but sometimes stranger things will happen and we'll be stuck using a Weibull or a Poisson distribution. So this is certainly a nice resource to have, and it comes with the package. So if you're interested in these tools, you're interested in learning more about this, please send me an email.